Welcome all to today's class. Today we are going to discuss 9th Standard Maths Chapter 2. Chapter name is Real Numbers. So we are going to discuss about real numbers. So number system. So what is a real number? Real numbers is a major division on the number system. So basically there are two types of number system, real numbers and not real numbers, that are called imaginary numbers. So we are going to discuss about the real numbers. So what is a real number? We all know the number line. So what is a number line? Number line is the representation of numbers on a line. You can see a number line. See, in this number line I have marked 0, positive numbers and negative numbers. So any number that can be represented on a number line is called real number. So what is a real number? The basic definition of a real number is any number that can be represented on a number line is called real numbers. It means that all these numbers that I have marked here is real numbers. So all the positive numbers 1, 2, 3, 5 etc. like infinity are real numbers, and all the negative numbers -1, -2, -3 are also real numbers, and all the numbers in between these numbers or in between these natural numbers or whole numbers are also real numbers. Since they also can be represented on a number line, they will also be real number. -0.5, this can be represented here, it is also a real number. So 0.5, √2, pi and all the negative numbers, everything comes under the name real numbers. We are going to see what is natural numbers. So natural numbers, the set of natural numbers starts from 1. 0 is not included in natural number. 1, 2, 3, 4, 5 goes infinity. And whole numbers, the set of whole numbers represented as W starts from 0. 0, 1, 2, 3, 4 goes to infinity. And the set of integers, I represented as I, and it starts from negative infinity and -3, -2, -1, 0, 1, 2, 3 and goes to infinity. So it includes all the negative numbers, all the positive numbers and also 0, set of integers. And next is the set of rational numbers represented as Q, and all the fractions in the form P by Q, where P and Q belongs to integers, can be called rational numbers. So and it is represented as Q, and the set of real numbers represented as R. All these number systems, natural numbers, whole numbers, integers, rational numbers, comes under the set of real numbers. See, and subset of W, that is natural number subset of whole numbers, means natural numbers are contained in whole numbers. You can see 1, 2, 3, 4 also they are also contained in whole numbers. So that means whole number contains natural numbers, and also whole numbers are all the whole numbers are contained in the set of integers. So that means natural number subset of whole numbers subset of integers subset of rational number. So all the integers comes under the set of rational numbers, and all the rational numbers comes under the set of real number. That means all these set of number systems come under the set of real numbers. You can see real numbers contain rational numbers and irrational numbers. So what includes rational numbers? All the set of natural numbers, whole numbers and integers. And whole numbers contain the set of all the natural numbers, and integers contain the set of all the whole numbers, and a rational number contain all the set of integers. So real numbers contain rational numbers and irrational numbers, and rational number contain all this number system. So we are going to the next topic, that is properties of rational numbers. So what are the properties? There are basic 4 properties of rational number. First one is commutative property, next is associative property, then identity property and inverse property. So if A, B, C are rational numbers, then what is the first property? Commutative property is simple, that is a addition. Commutative means addition. In addition, A plus B is equal to B plus A. That is simple. A plus B is equal to B plus A. And in multiplication, you can see A into B is equal to B into A. That is just, we have just inverse the order, that is A into B is changed as B into A. So it will not affect the value if we change the order of multiplication or addition. A plus B is equal to B plus A and A into B is equal to B into A. The next property is associative property. What is associative property? If A, B, C are rational numbers, then A plus B plus C is equal to A plus B plus C. So this is the associative property. A plus B plus C is equal to A plus B plus C. And same for multiplication. A into B into C is equal to A into B into C. You can see it here. And the third one is identity property. What is identity property? A plus 0 is equal to 0 plus A is equal to A. And the same for multiplication. In addition, the identity is 0, and for in multiplication, the identity is 1. A into 1 is equal to 1 into A is equal to A. These two are the identity property. You can see in this identity property of addition, identity property of multiplication for rational numbers. The next one is inverse property. What is inverse property? A plus minus A. Inverse of A is negative A or minus A. So A plus its inverse will be equal to 0. And for addition it is this. For multiplication it is A into the, what is the, for in case of multiplication, what is the inverse of A? 1 by A. So A into 1 by A and A get cancelled, it will be 1 for A not equal to 0. A not equal to 0, A into its inverse. What is the inverse of A? 1 by A is equal to 1. A and A get cancelled. The decimal form of any rational number is either terminating or non-terminating recurring type. So you can see terminating means it ends. When we divide 2 with 5, we will get 0.4. That means when we look and divide, you can see that I divide 5 with I divide 2 by 5 means dividing 2 with 5, I get 0.4. So it ends at 4. It not continuing. It means it is terminating at the point 4. So it is ending at that point. And also minus 7 by 64. When we divide 7 with 64, we will get negative 0.1099375. So it terminates at 5. So it is ending there. The division is ending there. It means it ends there. And 101 by 8, we will get 12.625. It ends at 5. It's not continuing. Like you can see in this, it is continuing. So it's not continuing in terminating type. In the opposite, in non-terminating type, when we divide 17 by 36 means we divide 17 with 36 and we get the answer as 0.47222, and the division will not be ending. It will be continuing like 2 to 2. It will be endless 2s. So it goes till infinity. So it is represented as with a symbol 4.2 dot. Dot means the 2 is repeating. So it is non-terminating. It is not ending at any point. It is repeating continuously. And in 33.26, 692307, this term is repeating endlessly. So it is represented by drawing a line above all the terms which are repeating. A line is drawn above that. So it is non-terminating recurring type. Means it is non-terminating, and it is recurring means it is repeating. A particular digits are repeating. So the dot or lines are used to represent the recurring numbers. And in this 56 by 37, you can see 5 and 3 is repeating. 5 and 3, 5 and 3, 5 and 3, represented by drawing a line above 5 and 3. So these are the two types of numbers, rational numbers, that's terminating and non-terminating. So in this we are going a question, express the recurring decimal 0.777 in p by q form. This is a recurring decimal number, we have to represent it in the form of a rational number, that is p by q form. How it is done? So 0.77, let x is equal to 0.77, so it can be written in short as 0.7 dot, it means 7 is repeating. We have to convert this recurring decimal into a p by q form, that is rational form. For that, what we are doing first we take, let x is equal to 0.777, that is equal to 0.7. it is, since it is 7 is repeating, we represent it in this form, dot form. Now we multiply the equation with 10. So when multiplying x with 10, it will be 10x is equal to, and here it is 0.777. So when we multiply this number with 10, we will get 7. This first one digit will be going to this side of the left side of the decimal point, 7.777, etc. And here it's only 1 7 here, so that one will go to this side. So the rest of the 7s will be 0.7 dot. So now we get another equation, 10x is equal to 7.77, etc. Now we subtract x from this equation, that is 10x minus x, that is 7. So what is here remaining on this RHS, 7.77, etc. minus, so this will be minus x. So what is x? You can see x is 0.77. So instead, in the place of x, we are writing 0.77, 0.77, repeating. So it is 10x. So what will be 10x minus x is 9x. 9x is equal to 7.77 minus 0.777. That is 7 will be remaining. All the decimals will get subtracted. 7.77 minus 0.77. So 0.77 gets subtracted. So 7 will be remaining. That is x is equal to 7 by 9. Equal to 7 by 9. You know what is x here. So we have taken x is equal to 0. X is equal to 0.7777 is equal to 7 by 9. So we have done with the problem. The question was to represent this decimal number in the form p by q. So we have done it. It's equal to 7 by 9 is the answer. You can see how this problem is solved here. X is equal to 7 by 9, and what is x? 0.777. So substituting, we get 7.9. So we are going to discuss about what is irrational numbers and rational numbers. So all the fractions that can be represented in the form p by q comes under rational numbers, and integers, whole number, and everything, natural numbers, everything comes inside rational numbers. You can see 4 by 8. 4 by 8 can be used in the form of p by q, can be shortened as 2 by 4. So it is rational number. And 0.75, it is terminating, so it is a rational number. And you can see negative 3, 0, 0.1, 0.48, root of 36 is 6, so 5, negative 10. So everything comes under rational numbers, all the whole numbers that starts from 0, all the integers and rational number, everything comes under rational numbers. So what is irrational numbers? So irrational numbers are the set of numbers that cannot be represented in the form of p by q, or it cannot be represented as integers, fractions with integers. You can see in this, all these fractions can be represented using integers. So in this you can see root 8. Root 8 cannot be represented as in the form of p by q using integers, and root 1.6, root 2 by 5, and minus root 11. This cannot, all these numbers cannot be represented in the form of p by q. And also in this example you can see 0.30300030. It's not non-recurring. you can see a pattern of repeating numbers cannot be found. We don't know what are the rest of the numbers. It will be 3 0 0 0. It will go on like this, 3 0 0 0 0, and it cannot be represented in the form of p by q. So all the irrational numbers means the decimal expansion can neither terminate or become periodic. That means it will not end, or it will not have a repetition pattern. We are going to the next topic, that is irrational and real numbers. So in this we are going to first to do a proof, that is the proof of root 2 is irrational number. The question is we have to prove that root 2 is an irrational number. Root 2 is an irrational number. For that we are using an indirect proof. That means we assume contradiction method is used here. We assume that root 2 is rational and we prove that it is wrong. Contradict the proof that it is wrong means root 2 is not rational. Not rational means root 2 will be irrational. So how we are going to contradict, or contradict means we prove that our assumption. We assume that root 2 is rational and we will prove that our assumption that root 2 is rational is wrong. That means it will be an irrational number. So we are going to see the proof of root 2 is rational number. So our problem is root 2 is an irrational number. We have to prove that. For that, first let us assume that root 2 is a rational number. We are assuming. So we assume that root 2 is a rational number. So root 2 can be rational means it can be written in the form of p by q. That is root 2 is equal to p by q. So root 2 is rational means it can be written in the form p by q. That is root 2 is equal to p by q. So we can, since it is square root can be cancelled, we are taking square on both sides. So the equation will become 2 is equal to p square by q square. That is, the q square is taken to that side. 2q square is equal to p square. So you can see 2q square is equal to p square means p square is a multiple of 2. 2 into q square is equal to p square. So it means that p square is a multiple of 2. P square is multiple of 2. That means that p square is an even number. Even number, that implies p is even number. P is even number means p can be written as p is equal to 2t. So again we took square on both sides, we get p square is equal to 2t square, where t belongs to I means t is an integer. So p square is equal to 2t square, and also we know that p square is equal to 2q square. You see we have written it here. P square is equal to 2q square, so we substitute this 2q square on the place of p square. So the equation, so in the place of p square I substitute 2q square is equal to 2t square. When taking squaring on both sides here, see it will be 4 here, not 2. See it will be 4 here, here also it will be 4 here, not 2. So 2q square is equal to 4t square. 2 on this side get cancelled, so equation become q square is equal to 2t square. This means q square is a multiple of 2. Since you see in the right side 2, it is a multiple of 2, so it means q square is even. That means q is even. So here now we have two statements. We got q is even and p is even. So q and p is even means it have a common factor. 2 is a common factor of p and q. So this is a contradiction to our statement that p by q is a rational number. If p by q is a rational number, p by q shouldn't have any other common factor other than 1. So 2 is common factor of P and Q. Here we got like that. So it is a contradiction, means our assumption is wrong. What was our assumption? Assumption was root 2 is a rational number. It is wrong, means root 2 is an irrational number. See, we got here contradiction since our we got contradiction here. See, what is the contradiction we got here? 2 is a common factor of P and Q. It is a contradiction since P and Q must have only one common factor, that is 1. That is the equation of the rational number. So it contradicts here. So our assumption is wrong. That is root 2 is irrational number. Irrational number. So we have proved the question. So next we are going to some of the properties of irrational number. So what are the properties? Addition or subtraction of a rational number with an irrational number is an irrational number. When we add or subtract a rational number to an irrational number, we will get an irrational number. We can see an example of that. 3 plus root 2. So here 3 is a rational and root 2 is an irrational. So when we add 3 to root 2, the answer will be 3 plus root 2 will also be an irrational number. And the next is multiplication or division of a non-zero rational number with an irrational number is also a irrational number. When we multiply or divide a rational number with an irrational, so here 3 is rational and root 2 is irrational, the answer will be getting is irrational. 3 into root 2 is 3 root 2, so it is a irrational number. And what is the last one? Addition, subtraction, multiplication, division of irrational numbers can either be rational or irrational number. So when we add, subtract or multiplied two irrational numbers, it can be either a rational or irrational. So we can see root 2 into root 2. When we multiply two irrational number, sometimes we will get a rational number. Root 2 into root 2 is 2, and root 2 plus root 2 will be like 2 root 2. So we get an irrational number. So this is our next problem. Prove that 3 plus root 5 is an irrational number. So the same way when how we proved that root 2 is irrational, in the same way we are proving the problem. So same way we are going to prove that 3 plus root 5 is an irrational number. So for that contradiction method, what will we assume? We assume that 3 plus root 2 is an rational number. We will assume the contradiction. Irrational contradiction is rational. So we assume that 3 plus root 2 is a rational number. That means 3 plus root 2 is equal to P by Q. Rational means it can be represented in the form of P by Q. Now taking this 3 to this side, equation becomes root 2 is equal to P by Q minus 3. Or it is not root 2, it is root 5. So root 5, the question is 3 plus root 5. So we got that root 5 is equal to P by Q minus 3. So we mark it as equation 1. So since P by Q is a rational number, P by Q minus 3 will also be a rational number. How it is? See, we have know that P by Q is rational. So 3 is also rational. So 2 rational. When we subtract a rational number from a rational, we will get answer will also be rational. So P by Q minus 3 will also be a rational number. So since P by Q is rational, P by Q minus 3 is a rational. Since 3 is a rational, so so we got that P by Q minus 3 is rational. So from equation 1, we know that P by Q minus 3 is equal to root 5. So the P by Q minus 3 is rational implies root 5 is rational. So what is equation 5? You can know in equation 5 root 5. What is equation 1? Equation 1 is root 5 is equal to P by Q minus 3. So this the right side of the equation, P by Q minus 3 is rational, means the LHS will also be equal to a rational number, that is root 5 is rational. So but we know that root 5 is irrational, so this is a contradiction. Root 5 is rational is a contradiction, since we know that root 5 is irrational. Since root 5 is irrational, so we contradict our assumption. So what was our assumption? Was 3 plus root 5 is a rational number. Our assumption was 3 plus root 5 is irrational, so we contradict it, means it is wrong. 3 plus root 5 is not rational, means 3 plus root 5 will be a irrational number. So we proved this proof. The next problem is write any 3 rational numbers between the 2 numbers given. So here 2 numbers are given, we have to find the 3 rational numbers between these 2 numbers. So before doing that, let us find what are the 1 and 2 are 2 numbers, rational numbers. So what are the numbers between 1 and 2? Numbers between 1 and 2: 1.1, 1.2, 1.3, 1.4, etc. 1.5 till it will go till 1.9. So this much numbers will be between 1 and 2: 1.6, 1.7, 1.8 and 1.9. So these numbers are between 1 and 2. So now what will be between 1.1 and 1.2? 1.1, 1.2. The numbers between 1.1 and 1.2. So it will be 1.11, comma 1.1, 1.12, 1.13, 1.14, etc. goes 1.19. So it goes on like this and ends at 1.2. That is 1.2. So you can see that this much rational numbers are between 1 and 2, and in between each one of them this much numbers are there. So when we goes on like this, there will be still more numbers between this, and it goes like an endless numbers are between any 2 numbers. So we have to write any 3 rational numbers between them. So I am doing this problem 5.2 and 5.3. So I can write any 3 of them: 5.2, 1, 5.2, 2, 5.29, etc. So many numbers will be there.